Hi, welcome to Chapter 7 Solutions. Today's tip is about the calculator. When you are using your calculator, as you know on the GRE, you will have access to a GRE calculator. It will be a simple 4-function calculator. So that means don't practice with a fancy calculator, practice with a simple one. And you may wonder, what's the difference? Well, the difference is that fancier calculators can do more things, for one, so they can take care of some things that you wouldn't be able to do on a simple calculator, and they can also compensate for some of your mistakes. So for example, some scientific calculators automatically do the order of operations for you, whereas a simple 4-function calculator would not. So therefore, you have to make sure you do the steps in the correct order in your own calculator. So if you have an iPhone like I do, and that's your calculator, use your phone like this, not like this. If you put it horizontally, that's when the scientific calculator comes up and you have more functions at your disposal. Okay? So if you're using this kind of phone, keep it up and you will just have a regular 4-function calculator, which I will be using for the next problem. Okay. Number one, we're told that Sean can run 26.2 miles in 4 hours and 6 minutes, and we're asked to find out how long it will take him to run 1 mile. Okay? So if you look at the answer choices are in minutes and seconds. So I went ahead and converted the 4 hours and 6 minutes into just minutes. So 4 hours is 4 times 60, gives us 240 minutes, plus this 6 minutes means it took him 246 minutes to run this 26.2 miles. We were told that he was running at a constant rate, and we want to know if he's just doing 1 mile, how long it will take him. That indicates that we can set up a proportion because it's a constant rate. So now that we have our proportion set up, we have miles to minutes compared to miles to minutes. We can cross multiply and forget about our units. So we get 26.2x equals 246 when we cross multiply. That times that equals this times this. Okay? We want to go ahead and solve for x. So we're going to divide both sides by 26.2. And I'm going to go ahead and put that in my calculator. So 246 divided by 26.2 is 9.389. Now notice the answer choices give us 9 minutes and 38 seconds and 9 minutes and 39 seconds. Both of those answers are wrong. Okay? So don't do all that hard work and then get the answer wrong. This is in minutes. So this is 0.389 of a minute. If we want to convert this into seconds, which we need to do, we'll keep this 9 because that's already in 9 minutes. In our calculator, if we still have the 9.389 up, just subtract 9 so that we have the 0.389 in our calculator, and then multiply that number by 60 because we want to convert it into seconds. Then we get 23 and some change, but since it's less than 23.5, we're going to just round down to 23. So the answer is 9 minutes and 23 seconds. Another clue that the answer is A is that it's the only one that's less than 9.5 minutes. Since this is 9.389, since this is less than 0.5, it has to be less than half a minute, and we know that half a minute is 30 seconds, so it has to be less than 30 seconds. And A is the only answer choice that gives us a number less than 30 seconds. Number two tells us that Keith takes 3 hours to rake leaves and Kevin takes 2 hours, and we're asked to find out how long it takes them to rake the leaves together. So if they're working together, it's going to take them under this 2-hour mark. Now, for this, we need to use the work formula, which is the rate of one worker times how long that worker is working, plus the rate of work of the other worker times the length of time that person is working. And that's going to be equal to 1 if they're doing one complete job. Let's say that they were only going to rake a third of the yard, then this would be 1/3. Let's say that they were going to rake the front and the back yards and they had the same dimension, then this would be 2 because they'd be doing 2 yards. Okay? So in general, if they're doing one job, then this answer is just going to be 1. Now, the first thing you have to do is figure out the rate of each individual. So the rate means how much work can they get done in 1 hour. So the rate is always going to be 1 over the total length of time that it takes you. So in Keith's case, it's going to be 1/3 for his rate, and for Kevin, it's going to be 1/2. Okay, so let's think about that. If it takes Kevin 2 hours to do the job, in 1 hour he can do 1/2 of the job. If it takes Keith 3 hours to do the job, in 1 hour he gets 1/3 of that job done. If it took somebody else 5 hours, in 1 hour they could get 1/5 of the job done. And then finally, sometimes they'll give it to you in terms of a variable. So let's say it takes somebody X hours to do the job. It's going to take them, their rate rather is going to be 1 over X. So it's just 1 over the total amount of time it takes them when working alone. Okay? So Keith, we've established, his rate is 1/3 of an hour, and 1/3 of the job per hour, and we're looking for the time working together. And then Kevin is going to be 1/2, so plus 1/2 times how long they're working, and that's equal to 1. Now all we have to do is simplify this equation. So this is 1/3 x plus 1/2 x, and that's equal to 1. We want to add these two terms together, so we need a common denominator. The common denominator is 6. So we multiply the 3 by 2 to get 6, so we have to multiply the numerator by 2. Over here we multiply the 2 by 3, so we have to multiply the numerator by 3. And now we can add our two terms together because they have a common denominator. So we get 5, 6x equals 1. To solve for x, we can divide both sides by 5, 6, or we can multiply by the reciprocal. If we multiply by the reciprocal, that would be multiplying both sides by 6 over 5. The reason we multiply by the reciprocal again is because the product of a number and its reciprocal is always 1. So this goes to 1, 30 over 30, you see, which reduces to 1, and you get 1x, so we can just put an x here, and 1 times 6 over 5 is just 6 over 5. If you look at the answer choices, they are not in terms of fractions or improper fractions, they're in terms of decimals. So you have to do 6 divided by 5, which is 1.2. If you don't know that, just put that in your calculator and you will get 1.2. So we'll take them 1.2 hours to rake the yard together. Number 3. Number 3 tells us that we have two trains, A and B, traveling southbound on a parallel track. Train A leaves at 9 a.m. and train B leaves 2 hours later at 11 a.m. We're told their rates, which for train A is 100 miles per hour and for train B is 120 miles per hour. And we're asked to find out at what time the two trains are going to be caught up. So when does train B catch up to train A? We don't know the time. However, we know that train B left 2 hours later. So if we make train A x, we'll make train B x minus 2. It's important to keep in mind that if we don't have to introduce a new variable, then we shouldn't. We want to keep everything based off of one variable if at all possible. Okay, and in this case it is. Now to find the distance, remember this formula, your distance equals your rate times your time. So you could, if you forget this, just think of dirt. Pretend the equal sign starts with an I, and you get distance equals rate times time, dirt. Okay, so with that in mind, we can multiply the rate and the time to get our distance, which is 100x. And for train B, it's 120 times x minus 2. Okay, it's times the whole quantity x minus 2. So because of that, I'm going to put x minus 2 in parentheses. If I fail to put parentheses, then I might only multiply the 120 times the x and then just subtract 2 instead of subtracting 120 times 2 once I distribute. Okay? Now, in this case, you have to figure out how to set up your equation. So if you think about it, when train B catches up to train A, since they started at the same place, by the time at that moment that train B catches up, the two trains have traveled the exact same distance at that point. So that means when train B catches train A, their two distances traveled will be equal. So that means we can set 100x equal to 120 times the quantity x minus 2. So here I'm going to distribute, and I'm going to get 100x equals 120x minus 240. I'm going to collect all my x terms on one side. So in this case, I'm going to subtract 120x from both sides. I get negative 20x is equal to negative 240. Don't forget that this minus carries down. Then I'm going to divide both sides by negative 20 to get the x by itself. And I'm going to get that x is equal to 12. So that means, since our time for train A is 12, it means 12 hours after train A left, train B catches up. So 12 hours after 9 a.m., which is when train A left, is 9 p.m. So the answer is 9 p.m., so 3 is D. Number 4. For number 4, we're told that Carlos has 3 times as much money as John, and Carlos then gives John half of his money, and we're asked after that exchange happens for the ratio of Carlos's money to John's money. So Carlos has 3 times as much money as John, so since Carlos's money is based off of John's, it's easiest to make John's amount of money x and Carlos's money 3x. Carlos then gives away half of his money, so half of 3 is 1.5, which means he now only has 1.5x left. That 1.5 that he gave away is now added on to what John has. Well, John has 1x, so another 1.5x would be a total of 2.5x. And now we simply need the ratio of what Carlos now has to what John now has. So that is going to be 1.5x to 2.5x. Now, if you look at the answer choices, there's nothing there that looks like this. So that should give you a clue to say that we can simplify this ratio. So for example, we have x's on both sides, so we can divide by x on each side of our ratio, and we get 1.5 to 2.5. Then you'll notice that we have decimals that are unnecessary. If we multiply both sides by 10, this becomes 15 and this becomes 25. So multiplying by 10 simply means move our decimal one place to the right if we want to take a shortcut. So our ratio is 15 to 25. And then finally, you'll note that both of our numbers are divisible by 5. So 15 to 25 can be rewritten as 3 to 5. So our answer for number 4 is C. Number 5. Number 5, we're told that Tanya invests her money in 2 different bonds. One has a 4% yield and the other has a 6% yield. We're also told that she invests 5% of her money into these 2 bonds. That 5% actually is not important to the problem because we want to know the return on her actual investment. We want to know the return on the money she invested. We don't care what portion of her overall money was invested, just how much she earned relative to her investment. So let's say that Tanya's investment was X dollars. We're told that she invested 80% of the X dollars in bond 1, which was a 4% yield. And she invested the other 20% of the X dollars at a 6% yield. So to find her interest, we need to know how much she invested times the rate she was getting back, and that would be her total interest. So let's say you invested $800 at 10% rate, you'd be getting 800 times 10% or $80 in interest. So this is the same thing, it's just that we have percents and variables in ours. Okay? Now you can use your calculator for this if you wish. We have 80% of X times 4% of X. That gives us 80% of 4% is going to be 3.2% of X. Okay? If that confuses you, just put 0.8 times 0.4 into your calculator and you'll get 0.032, and to turn it back into a decimal, you're going to move it over 2 places to the right. Same here. You have 20% of X times 6% of X. So you want 20% of 6, which is going to give us 1.2% of the total money invested. So the total interest that Tanya got is going to be how much she got from bond 1 plus how much she got from bond 2. So we're just adding these columns and we get 4.4% of X. So her return on investment is 4.4%. You could have multiplied and kept your answers in decimals. If you kept it in decimals, you would get 0.044x. And just remember to turn it back into percent at the end to get the 4.4%. Okay? The final thing I want to say on this is that we could have simply said that Tanya invested $100 because everything is all relative. So if she invested $100 total, that would mean that she invested $80 in bond 1 and $20 in bond 2. So $80 and $20. She got 4% of $80, which you put that into your calculator, you're going to get $3.20. And then here she got 6% on her $20. So that's going to be $1.20 for a total of $4.40. So you can see that $4.40 is 4.4% of 100. We know that $4 is 4% of 100, so 4.4 is 4.4% of 100. So that might be a bit easier and less abstract. Number 6. Number 6, we are told that Kelsey is half of her brother's age, or at least she was 5 years ago, and that her brother is now 5 years less than twice her age. And we're asked what age her brother could be out of a list of ages. Okay? And we have to choose all that apply. So, Kelsey is half of her brother's age. So if her brother is X years old, then Kelsey 5 years ago was half of that X. Now, we need to know how old they are to fill this in. So, if 5 years ago somebody is X, now he would be X plus 5 because 5 years have passed. Same for Kelsey. If Kelsey was half X, now she's 5 years older than half X. Now the next thing we have to do is come up with an equation. So we're told that Kelsey's brother is 5 years less than twice her age. So if we double her age and take away 5 years, we can set it equal to her brother's age. So Kelsey's brother's age is 5 years less than twice Kelsey's age. 5 years less than that, so I have to take away 5 off of the end. Okay? Now I'm going to simplify both sides. We'll really just simplify this right side for now and then solve for x. So I get x plus 5 equals, we're going to distribute here. 2 times a half is just 1. Remember that 2 is over 1, so we get 2 over 2. You also might notice that 2 and a half are reciprocals. So we get x plus 10 minus 5. If we continue to simplify the right, plus 10 minus 5 just becomes plus 5 because I'm going to do 10 minus 5. Over here we get x plus 5. You're saying, you might start to notice, okay, we have the exact same thing here. You might know we can stop or you might keep going. You subtract 5 from both sides. You get x equals x. This is simply an identity. This will always be true. So, since we have x equals x, this actually means that Kelsey's brother can be any of the ages listed. So, for example, age 18 is listed. So, let's say that Kelsey's brother is 18. Half of 18 is 9. Kelsey would now be 14 years old. Kelsey's brother would be 5 years older than 18, so he would be 23 years old. And 23 is 5 years less than double this. Double this is 28. Take away 5, you get 23. Let's do a second one. Let's say that Kelsey's brother is 34. Then Kelsey would be half of that, 17. 5 years later, Kelsey would be 22. 5 years later, her brother would be 39. So, 39 has to be 5 years less than double this. Double this is 44 minus 5 is indeed 39. So this relationship will always hold no matter how old Kelsey's brother is. These will all be true. So the answer is A, B, C, D, and E. Number 7. Number 7, I'm going to go ahead and read this one. We're told that James needs a solution that is 10% sodium. However, the only two mixtures available are 5% and 12% sodium. What is the ratio of 5% solution to 12% solution needed to reach the 10% balance? Okay, so here we need to figure out how many ounces of 5% solution we have to put in and mix with 12% solution in order to get a result of 10% solution. And we actually just need the ratio, so we need to know the balance of the ounces put in. So let's say that we use X ounces of the 5% solution, then the total amount of sodium we have given the 5% solution is just 5% times X. So 5% X. Okay, now for our 12% solution, normally I don't like to introduce new variables, but if we can't help it, then we have to introduce another one. So we don't know how much we need relative to X, so we just need to introduce a new variable, which in this case will be Y. So the amount of sodium we now have is 12% Y. Okay, if this is sounding a little abstract to you, just put in a number temporarily here. Let's say that we had 100 ounces of a solution that was 12% sodium, then it would be 12% times that 100, or 12 ounces of sodium. Okay, so keep that in mind. So now we want to get a 10% solution. Well, this is going to be additive. If we have X ounces of 5% and Y ounces of 12%, then we have X plus Y total ounces going into this 10% solution. Now, this actually, we're not going to add down this way. We're going to add across because we want to be able to set up a second equation. So if we have a 10% solution of X plus Y ounces, we end up with 10% of X plus Y ounces. So this sodium plus this sodium is going to equal this 10% balance of sodium. So 5% X plus 12% Y equals 10% of X plus Y. So I'm going to go ahead and turn these into decimals, and I get 0.05X plus 0.12Y equals, I'm going to turn this into a decimal and distribute at the same time. So 10% of X is going to be 0.10X, and 10% of Y is going to be 0.10Y. Now remember, we're looking for the ratio of X to Y. So I'm going to go ahead and collect all my X terms on one side and my Y terms on another. So since I have a greater amount of X over here and a greater amount of Y over here, I'm going to collect my X terms on the right and my Y terms on the left. Okay, so I want to remove this 0.05X from the left side, so I have to subtract it over here as well to keep it balanced. At the same time, I want to get rid of this 0.10Y, so I'm going to subtract that from both sides. Now when I simplify this, on the left I'm going to get 0.02Y, which is equal to 0.05X. I'm running out of room here, maybe I should slide over. Okay, so I'm going to just recopy this equation over to here. So I have 0.02Y plus is equal to 0.05X. Okay? Now I need to solve for one variable in terms of another. Remember what our goal is. Our goal is to find the ratio of X over Y. Okay? So I'm going to divide both sides by 0.05 to get the X by itself. And I get X equals 0.4Y. I didn't have to keep it as 0.4, especially since I don't have decimals in my answer choices. I could have written this as 2/5. If I multiply this by 100, I get 2, and I multiply the denominator by 100, I'm going to get 2 over 5. So that's probably the better way to do it. I'll just go ahead and change that now, although the 0.4 will work also. I think that's the way I have it in the book. Okay, now remember again, we want X divided by Y. So we have X by itself. We want to get this Y underneath, so we're going to divide both sides by Y. So you get X over Y is equal to 2 over 5. So our answer is B. If you had kept this 2/5 as 0.4, then you could just test the answer choices to see which one is equivalent to 2/5. Or you could have written 0.4 as 4 over 10 and then reduced to 2 over 5. So either way, you would get that x over y is equal to 2 over 5. Answer B. Right, number 8. Number 8 tells us that New City had a growing employment sector, which resulted in a population surge of 5%. That 5% brought the population to 112,000 residents. So this 112,000 is post-surge. And we are asked to find out how many residents we had before the population increase. Okay, now the classic mistake is to take 5% off of this number or to multiply this number by 95%. But most students would take, if they do it incorrectly, would take 5% off of this number and come up with the wrong answer. Because this 112,000 is, again, the post-surge. So this does not represent 100%. This represents 105% of the original because it includes everybody who was originally there plus an additional 5%. So remember, whenever you're setting up these equations, you have to know how your actual number relates to the percent given. So we're given 5%, but we know that this 112,000 is 105% of the original, and that is 112,000 people. So X would be the pre-surge number. Keep that in mind. That's the original number. So this 112,000 is 100% plus an additional 5%. So 105% of the pre-surge number is 112,000 people. Okay? 105%, if we drop this percent sign, we are going to get 1.05x equals 112,000. And then we are going to divide both sides by 1.05. And remember, we're asked for the approximate number of residents pre-surge because we are going to get a decimal. Okay? So 112,000 divided by 1.05 is 106,666 and 2/3. And the calculator would get 0.6 repeating. Okay? So we're going to round this number up to 106,667 people. If you add 5% onto this, you will get 112,000. Okay, so that's one way to check your work. If you find out what 5% of this is and add it to 106,667, you will get approximately 112,000 residents. So the answer to number 8 is 106,667. That concludes Chapter 7. Now make sure you go to the official guide and do the associated problems with Chapter 7, and then come see us back for Chapter 8. Good luck.